What I'm going to talk about today is work done, work, and energy. So I will start from work first. Work is a form of a kind of energy that's only applied on a moving object only, and this unit is in joule, only joule. And the formula for work done is W equal to F D. F here is force, and D here is distance. We can measure D in meter and F in Newton only. And here is an example. The shock from point A to point B, and that is work done. And that is the distance. My power for my finger is a force that push the shock away. Point A, point B. Distance, you can assume that you can describe for this 10 5 times 10 equal to 50 J. And I'm not yet done.
Erase the feet.
And for the energy topic, there is at least two kind of energy. Kinetic energy, you can write it in K, and potential energy in P. Kinetic energy is for the moving object, the object that in motion. The formula for this KE is 1 over 2 mv squared. And for potential energy, is for the steady, the stationary object at the height. We can use mgh for this P, and I will let the other scientists talk about the rest of the physics world. Thank you.
Okay, now I'm going to talk about power. Power is the rate of doing work. It's the amount of energy consumed per unit time. Having no direction is a scalar quantity. In the SI system, the unit of power is the joule per second. The formula we use in power is P equal W over T. W is a work done. T is time. The example is the man walked to point B. His time is 2 meters, and he used 5 seconds to go to point B and use 2 Newton. So we have to find work done first before to go to find power. The formula of work done is W equal FV. F is a force, E is a distance. So we put number to the formula. W equal 2 Newton times 10 the work done equal 20. Now we know work done equals 20. So we can use this formula to find power. Equal work done is 20 and time is 5 seconds. So the work done is 4 joule per second. So is the definition of power and how to find power. Thank you. ก็เป็นภูเก็ต Universal Authority เลย So I'm going to talk about universal gravitation. Universal gravitation is attraction between two masses. So there is a law that's stated by Newton that any two mass attract each other with a force equal to a constant G multiplied by the product of two mass and divided by the square of distance between them. So this is it. If the case is for Earth and other objects in the universe, we can describe this one also as which this means gravity, mass of the Earth and this is radius of Earth. And the distance between from the radius to the object.
And here is another example of me as a bigger object and him as a smaller one.
So we will show you how you explain that how the formula works.
What are you? State what are you? I'm a tough boy with a muscle, six pack, chest muscle, and bicep.
And I'm careful. Then I will attract it to that guy.
Then what happened here is
So he has the force to pull me to attract him. So as we know that formula, if we far away, the force will be lower. If we have more mass, the force will be greater. So as you know that with this formula. Why doesn't he move? Because of he have more mass than me. So he will be live there, and I will move because of I have little mass.
So I'm going to talk about circular motion. I'm going to define what is circular motion first. Circular motion is where an object is moving in a path in a circular way. In this case, the object moves around its axis, around here, and then move around in a circle. And there are two types. First, non-uniform circular motion, which is different from uniform circular motion because they have difference in speed, which is v. So they have tangential acceleration. So in that case, we have the acceleration here, the tangential acceleration here. The tangential acceleration doesn't go towards the center of the circle, but towards between the way of the speed and the centripetal acceleration. But in this case, we don't talk about non-uniform circular motion, and we only talk about uniform circular motion. In such case, they have V and they have Fc, which is centripetal force. And we don't have this because V is constant and not changing. For circular motion, we have many formulas, but I will only introduce the important ones. The first one is F equal m a. From here we can say that m and a is centripetal acceleration, so it is b squared over r. This is to find centripetal force from mass here, the mass, and the acceleration. And in circular motion, we have tangential and angular units, symbols, and they are quite closely related to each other because they can be found by using some patterns, such as that S, which is tangential unit, tangential symbol, and S is equal to delta zeta times radius. The radius is here. And the second case is V, the tangential speed, is equal to omega times r. So in these cases, we can see the pattern that the angular symbols times r is equal to the tangential symbols. And as I explained in here, most of the angular circular motion formulas are derived from the linear formulas, such as that V equals to distance over time. In this kind of formula, we can say that velocity is omega, and this time is zeta, and t is the same. So they can be changed just by changing the symbol, which is this one is by changing to the corresponding symbol, such as that d is corresponds to zeta, b corresponds to omega, and t is the same because they have the same thing and they can use same stuff. Okay, from here there are many formula like this, and we can change the formula by just doing this. So it can be used for most of angular formulas. Okay, so I'm going to move to the challenge question, challenging problem. Okay, wait. So by looking here, the question states that this is the starting point and the object is moving in a circle. This is a uniform circular motion, and they have the omega here, I mean the tangential speed here, b, and they are turning this way, and the I is given as 1 meter, and mass of an object is given as 1 kilogram, and they also given the 12 meter height, and this is the starting point, which is 0 meter. And the question asks, what's the minimum centripetal force needed in which an object reaches 12 meter at max? So an object is released at this point and reaches this point with the velocity of 0 meter per second. So I'm gonna solve this question. First of all, you need to find what velocity needed for the object to reach here. So one of the linear motion formula we have only one formula that doesn't need t, because they don't give t, which is Vf square is equal to b o square plus 2as. This is linear motion formula, and Bf is unknown. Bs is known as 0 meter per second, so this is equal to 0, and Vo is not given, so we can say Vo square plus 2, and A is a gravity, which is minus 10 meter per sec square. And S is given 12. Okay, so I'm gonna use the calculator to calculate this. So the answer is 15.49. Okay, so now we find out the velocity here, which is 15.5 meter per second. From this we can find the Fc, which is centripetal force. So we're gonna use the formula that I gave in the last video, last one, and which is Fc is equal to mv square over r. Okay, the mass is given as 1, and the V is given, we got the value of 50.5 square, and R is 1, so we can just cancel this, and we can say that 15.5 square, which is around 240.
Okay, now I'm going to explain about rotational dynamics. So rotational dynamics is the moment of inertia, or as we know as rotational inertia. It is, we have two forces apart each other, and we rotate that to force something like this one. We have force, we have mass here, and then we have mass here, and we rotate this to this dynamic, rotational dynamics. So the formula given is I equal to M square. So if we have more mass, the gravitational dynamics will be more, and if we have radius more from here, we will also have rotation,
more inertia.
more inertia.
Something
like that. So I will make an example.
Don't be like
We have mass here 2 1 kilo here and 3 kilogram here 2 meters. The formula they given is equal to m squared, and then we put m is 1 squared plus 3 kilo and radius square. So in total we get is
meter square.
done. So this is the moment of inertia. Easy. Physics easy.
Finish.
So
No idea.
another topic of this one is about conservation of angular momentum. So we have the mass the same. This 2%, 10 kilograms. Yeah. And this person have length 0.1 meter. But this one we have 1 meter. So if we look the conservation of angular momentum of this person, the velocity will be faster than this person. Why is it faster? Because of the inertia he has less, and then velocity of it will be higher. And this means the inertia will be higher and velocity will be lesser. So this one will be what each other of conservation of angular momentum. Easy physics.